Hey, what's going on, folks? It's Mike here, and welcome back to my Deep Programming Language series. In this episode, we're going to be taking a look at opCall. So if you're coming from a C++ background, you're going to be familiar with the term functors. Well, this is sort of the idea in D, in which we have opCall, which overloads the parentheses. So it allows us to basically treat an object, a struct or a class, like a function, or perform a function call on it. Now, if that's a little bit confusing, we'll go ahead and do some examples just to clear this up. But again, generally, this is the idea or flavor of just how to use the feature. Now, I'll try to give you at least one example as well as how to use the feature, but let's go ahead and take a look at it now on the Dlang website. So I'm going to go down to documentation, the language reference, and we're going to go to operator overloading here. And if you haven't seen my previous video on operator overloading, you might want to check that out. Again, that's going to give you a little bit of background about what this is. I think you can get through this video without it, but again, you might want to still go back and look at how to overload things like plus and minus, times, and other symbols, just so you have an idea. But anyways, we're going to overload the parentheses today with a special function call syntax here called opCall. So anyways, let's go ahead and take a look at it here. Let me go ahead and minimize my window here. And we'll scroll up to the function call operator overloading. So the basic idea of this, and we'll just kind of code along a little example here. Let's say we've got some structure here or some type. Again, it could be a struct or a class. I'll call it resource manager, for instance. Let's give some fields here. Let's say field 1, field 2, and then let's create some data here. Let's just go ahead and make it an array of, whatever the data is, maybe some numbers. In practice, a resource manager might be files, different types of data types, and so on. You can think of it like a file system. But anyways, what we want to do here and then is just create something called opCall, which is a special syntax in the D language here. Again, the compiler is going to look for opCall and know what this means. And again, overload basically these parentheses here. So let's go ahead and just do a simple example to get started here. And I'll just use right line here, and we'll just say opCall. And I'll go ahead and put, resource manager.opCall here, just so we can see how this works here. So what I'm going to want to do here is create my resource manager. Let's say R here, and then I'll just use R and then the parentheses, and I'll run it. And simple as that here. Okay, so it's just the parentheses right on the type here. So I didn't need to do anything, for instance, like go here and call this, function call, whatever this would be named. So again, let's try to compile this, right? Without the opCall, we'll get an error saying, hey, we haven't overloaded the parentheses, right? Because we have this instead. We have function call, okay? So we don't have to give a name to something, which is kind of the nice, basic feature of opCall here. And again, it can make things relatively clean here. Now, this could be very useful in D when we talk about things like string mixins, for instance. If we just want to, like if we're just changing the type or trying to write generic code and we don't know the function name, but we know we can just call on the actual object with the parentheses. That's why we sometimes call this like function object or functor in other languages. Again, in D, it's fine to just say opCall. That can be very useful. So it can be useful for that feature here. There is another feature we talked about, though, if you're saying, well, Mike, maybe we do want to give names to things. We do have opDispatch will, again, be a default call to some function if we don't know the name. So let's say, for instance, we had something like this here, r dot, some setup function here. And let's run this. It'll give a little error here. And then I need to do void opDispatch. So this is going to be a similar syntax here. So just give us a moment here. Let's call opDispatch here. And this will be a good test for you to see if this code compiles or not. Good little test for me too. And you might want to go check out my opDispatch video otherwise here. So is this going to work? No, this isn't going to still work here. Okay, so opDispatch must be a templated function so we can kind of recover this setup function here. So let's go ahead and put the template here, opDispatch, and then we'll just put the type, whatever it was here. Let's see here. Oh, it gave us no property setup for R, potentially malformed opDispatch, etc., etc. And again, the error message is giving us says potentially malformed opDispatch. Use an explicit instantiation to get a better error message. Okay, so what do I need to do here? Well, I just need to be a little bit more patient and make that a string. And then we should be good to go. Okay, so now we can actually see what the function is called. Again, opDispatch is sort of our catch-all. opCall is to just actually call on the object. Okay, so let's just go ahead and make a note here. opDispatch is a catch all, right? And we can decide if we want to handle this, right? If there's no function or any function in the family of things that might be trying to call this called like setup or initialize or whatever. And then this is a specific call, specific call on an object using just the parentheses. Okay. Now a few other things here about this that are important. Let's go ahead and add some arguments here, maybe for our field 1 and our field 2, for instance. So let's go ahead and assign these field 1, field 2. Okay, and let's go ahead and again, let's compile this. Let's see what happens here. We're gonna get some errors. Okay, let's reveal those errors here. It's gonna tell us too few arguments, so we still gotta obey our laws here. It is just like a regular function call, and let's just put in 1 and 2 here, just to get something kind of interesting, and that'll work just fine here. So we can have arguments, we can have a return value, we can do all these sorts of things here. You can even do interesting things where I assign this to some other value, but anyways, that is with opCall here. Now let's go ahead and test another thing here. So let's say I want to construct my resource manager using maybe just let's do all 3 of the fields here, something like 1, 2, and null. And then I can get rid of this here, right? Because I don't need to initialize these values here. Okay. And oops, now I'm getting a problem here saying function opCall is not callable using argument types int, type of null here. Okay, so it's getting a little bit confused here. And then saying expected 2 arguments, not 3. Okay, so let's get rid of this here. And I'm getting another error here, calling non-static function. Okay, so we got to talk about functions here. Basically what I'm trying to show you here is as soon as I have opCall, this is going to conflict with something that we get for free. Okay, again, this is going to really test your D knowledge here. It always tested mine when I learned about it, but it's this bullet point down here. Number 3, note that merely declaring opCall automatically disables the struct literal syntax. Okay, if you don't remember what the struct literal syntax was, let me just remind you. And this is easy for me to do. I'll just comment out opCall. And again, this is only for structs. It'll work. Now, why does it work? Because again, struct literal gives us all of the constructors for free, right? It'll give us a constructor that just initializes field 1, a constructor that can do field 1 and field 2, like we have here, and a constructor that does field 1, 2, and 3, for instance. Okay, so I could actually, again, let's put in a null value here just to show different constructors working. Again, that's what the struct literal syntax gives us. So, just keep in mind if your classes get large, that is something that you have to deal with. Now, how exactly to deal with this? Let's go back to our opCall here so that we know the difference between which is being called here. Let's create a constructor here that takes in, field 1 and field 2. And I'm just going to paste this in here like such. And let's see, is this going to work? This is going to work here, right? So the fix is just to define a constructor. So we know explicitly while we're doing construction that we're not trying to do some like opCall thing and return a type here. Okay, so simple enough. There we go, have it. And our code is working here. So again, make sure when you're using opCall, you play nice with constructors. Again, that's just so the D language knows what to do. It does bring up sort of an interesting use case you might consider, though, where you could construct a type and then do opCall to maybe initialize the values. Again, you could probably get away with that for structs. You got to be careful with that with classes, because with classes you still need to do equals new at some point and allocate the object. So just be a little bit careful. I tried to play around with that, but overall I found it's nice to have constructors do the job of construction and then opCall do some work or some task here. Okay. All right, now let me go ahead and scroll down here a little bit to static opCall. So what if we make our opCall a static function? Okay, so a good little reminder here of what that'll do. And let's just go ahead and attach static here. Let's see if we can use it. Is this going to create an error or not? What do you think? That's going to create an error, right? These are non-static fields here. Okay, so if I have a static function call as one of my member functions, again, this is going to cause a problem here. So that's why we're getting these errors here. Okay, so what might be the purpose here? Let's go ahead and remove that. Get ourselves in a good state. Well, if I have something like a resource manager, and let's give a little bit of context here. Assume resource manager only has one instance in our program, or maybe just part of it, should only have one instance. So what I mean by that is, let's say I have a static variable here, and I call this, let's just create a new little type here, a resource, okay, just so I have something here. And this is going to be an array of resources, okay, something like that, and s, resources, and it's static again. So static members are shared amongst all instances of our resource manager. And let's actually put something in here just to make sure it's not like totally useless, value, or a key or something, or like a globally unique identifier, something like that here. That's what GUID stands for, globally unique identifier. Okay, so let's compile this. Still compiling. So now how I might use this, or kind of a nice use case of this, is to use opCall. Let's return a resource. This is just an array, so we'll just need an index here. opCall, and its index, which would be positive, something like that here. And we'll return s, resources at index here. Okay, something like that here. Okay. All right, so let me go ahead and let's split our window here just for a moment. Oops. And let's see here. Let's do, let's see here, 5, control. Let's shrink that just a little bit here. Or sorry, let's just go, let me scroll down here just to give you a use case of this. So anyways, if I have my resource manager here, now that I've got opCall, let's just compare this if I didn't have opCall with something like get resource, right? This is how I normally write this function, get resource, okay? So, I mean, clearly these two functions are doing the same thing. But what I might want to do here is just use resource manager again, because it's got this, static resource here that's shared amongst all instances of resource manager. That's how I call it. Like I call get resource, 0, let's say here, or I could just use it with this here, the opCall. Okay. Same thing. The one at line 45 uses opCall. Okay. Let's see if this compiles first and foremost. I mean, it might give us a segmentation fault because we don't have any resources there, but let's see here. Oh, undefined resource. Yeah, let's make sure we uppercase this. So if you do copy pasta, you get the error twice here. Oops, and yep. How did this get all lowercased here? There we go. Resource. Okay, let's see. Oops, what's happening here? Calling non-static function, etc., etc. It requires a type of this. Okay, so what did I forget here? These need to be static. Okay, static. I'm all set here. And let's see, not callable. Okay, well, we got to be careful. And wow, I really messed up the capitalization on this. Remember, it has to be opCall with capital C here. So there we go. Get back in action here. And let's see. Well, as I mentioned before, it's, the fix before for our struct literals was to say, let's define a constructor so that it explicitly knew what was going on here. So it's saying, okay, not callable using arguments int. So again, it's thinking that this is some sort of constructor here at line 45 here. Okay, so let's see if we can, let's go up here to our constructor. Let's go ahead and give ourselves int, f1 here. And let's define the body here just for completeness. Let's see if I can discern between our opCall and constructor call. Yeah, now it can. Okay, so you do need to define these. As I mentioned, okay, it's going to give us a index out of bounds error here. So let's go ahead and just give ourselves a resource. Resource manager, let's see, .s resources, append equal, I don't know, our resource. And let's see, what's in our resource? Well, I just gave it a integer, I don't know, 1 here. Okay, so now it'll work here. Okay, let's do a little bit of code review here because we covered a few different things here, but a few important things and, well, some things that I think are going to be quite nice for you. So first and foremost, we have this resource manager that we created here. We've got a few different fields and one of them static. Okay. So again, just to review what we did at the start of the video, we have opCall, which allows us to just call on instances of this type here, resource manager, with the parentheses. So no problem there. And then we could sort of use as is. Now, again, opCall is different than something that's called opDispatch, which we covered in another video here, which is sort of our catch-all, using any type of function that we can't find by name. And opCall is using explicitly the parentheses and whatever the arguments are. Now, because we've defined opCall, though, that's left us in a little bit of a situation here where we need to be explicit about our constructors, and I sort of recommend this for whatever versions of opCalls you have. As you can see, I got in a little bit of trouble there towards the end of the video. But anyways, the next idea then, after understanding that we lose our struct literal capability with structs, is that I can have static opCall as well, no problem. And this is actually a use case where I kind of like it, because what it allows me to do is just call resource manager 0 here and not have to define a bunch of these functions like get resource, for instance. I mean, these are still pretty explicit, so they're kind of nice to grep for. But if you find yourself having, really long names or types or, these types of things here, this might be an option where it makes sense. So I've used this, for instance, when I do graphics programming and I just want to sort of have a, if I have like a key value pair or some map that's part of this resource manager, it's nice to just say, have the opCall version. You could still define the get resource or get key or get value function if you want, but this could be a little shortcut for you. And again, these types of things could be more important if you start doing generic programming and want opCall. So it is something that you have to decide. The debugger will still, pick up things like opCall, but if you find it useful for readability to have get resource, that's kind of a trade-off here. So it's a shortened syntax, which is kind of nice, and it might make your life easier when doing generic programming to just have some function available. But again, that's what you have some things like opDispatch that are super, super useful for. So anyways, this is just another tool to add to your tool belt, so to speak, and that you can use in the deprogramming language. So let me know your thoughts. Let me know if you use opCall. Let me know if you think it's a useful feature and that's something that you found helpful in your code, or if you prefer to just do the explicit calls and don't mind having long names of things. Again, that can be sort of self-documenting. But again, I have found it really nice to write concise and very tight code, especially if I have a data type that only really does one thing, like stores resources. Then I can sort of infer pretty well exactly what it's doing. And again, I don't have to expose the container or something. So again, your options are to write a function like this or just use opCall. Anyways, I think we get the idea. You can take a look at this code one more time here, just as an example. And if you want to check out those lessons on opDispatch, operator overloading, etc., you can go ahead and check out the deprogramming language series on courses.msha.io, but hopefully you know about that already. And anyways, folks, thanks for your time and attention. Thanks for bearing with me with some capitalization errors, but hopefully you had fun. Hopefully you learned about a new feature, and I'll otherwise look forward to seeing you in the next one.